So students are not with you, they are in their lab, home, is it?
No, sir. They have arrived at our place.
Okay,
There
okay.
are total 8 students in our class, and the rest of the people will be joining from different places.
Okay, okay. So let me start sharing. So, all right. So, I will make it full screen. So I can, are they able to see, watch this?
आपको दिखाई दे रहा है? Yes, sir. They can see it.
Okay, so maybe we'll wait for 5 minutes.
Okay.
And so that people, anyone else who wants to join can join. And I will start whenever you tell me, ma'am. So I'll talk for about 20 minutes. And after that, we will have the activity. And after the activity, we can have questions. That's okay, no?
Okay, sir. Okay.
Maybe I should put everyone on mute so that background noise will not be there. Mute all current and new participants. Vinita, you can unmute yourself so that we can keep communicating.
Okay, sir.
Yes, okay, that is good.
Be quiet.
Yeah, now I think there अच्छा आपके या उनका आवाज नहीं आएगा अभी I think.
Okay, sir. I think we can start. The
All
people
right.
will be joining in between. I'll admit them.
Okay, okay. All right. Welcome, children. It's good to be here and to talk to you. So today I want to give a short introduction to how big is our universe. Then we will do 2 activities and then you can ask your questions. Okay? So, how big is our universe? Let's try to understand sizes of various things. So, what I'll be showing you is a set of slides called powers of 10. Here there is, in this square, the size is shown. Right now, the size of this square is 1 meter by 1 meter. The side of the square is 1 meter, which, as you know, is 10 to the power 0. So here is a person enjoying himself, resting in a park. And every new slide, the box will be made 10 times bigger. So the next box will be 10 meters, then the next box will be 100 meters. And this box will become 1/10 smaller than what it is now. And you will see a bigger area. You'll see more things, and then we'll go out and we'll zoom out. You understand, zoom out. We'll zoom out. Okay, so we have zoomed out. This box is now 10 meters wide. The square is 10 meters wide. Here is the person in the park. He is now in his original 1 meter square. And you are getting a view which is 10 meters by 10 meters. Let's go out. Let's make it bigger. So that's the story now. We are going to see the entire universe in sizes of 10. Okay, so now this box is 100 meters by 100 meters, which is same as 10 to the power 2. And the person is in the middle. Always the person is in the park is in the middle. We cannot see him now because he's very far. But here is the person in the park, and here is the larger view of the park. Now let's make it even bigger. Next slide. So now you can start seeing the city. Here is the city of San Francisco, or it could be Delhi or Mumbai or any Indian city. The size of the square is now 10 to the power 3 meters. 3 zeros followed by 1, right? So we'll add 110, we'll add when we go to the next slide. So this is about 1 kilometer by 1 kilometer. You see a huge park.
Sir, there is a request. Can you please speak louder because we are not able to hear it correctly.
Okay, is this better?
ये सारे आ गए हैं and
Yeah, is it
थोड़ा सा
better
अगर
now?
हिंदी में बोल देंगे ना तो मतलब इनको थोड़ी सी
हाँ,
और
अभी
क्लियर
ठीक
हो
है क्या?
जाएगी
अभी ठीक है?
हाँ जी सर हाँ जी
All right.
ओके
So this park size is 1 kilometer by 1 kilometer. अब इसको और बड़ा करते हैं. So Hindi is preferred. Hindi is the preferred language. Okay. So we will now go to the next view. We'll make it 10 times even bigger. Now you can see the part of the city. This is the city of San Francisco. This square is 10 kilometers wide. One followed by 4 zeros. There's one followed by 4 zeros. Okay. And here you can see the city. The original person is here. The garden is here. This is the boundary of the city. Now here you can see water. You can see the sea. The ocean is here. And we are making the square, the covered area, bigger and bigger by zooming out. So let's zoom out once again. This is now, you can see the city. The person in the park is here in the center. The person in the park is now here in the center. The garden is somewhere here. And here is the ocean. And now you can see the boundary of land, and you can start seeing part of the earth. Okay. And this is how much distance? 1 followed by 5 zeros, 10 to the power 5 meters, 100 kilometers. So this size is 100 kilometers. Let's go to the next slide.
इनसे पूछ ले इनको समझ आ रहा है क्या कैन वी वेट फॉर अ व्हाइल
Yes, yes.
यस आर यू पीपल एबल टू अंडरस्टैंड
Yes, ma'am.
झूठ तो नहीं बोल रहे हो यस यस कह ओके सर ओके सर
Okay, so now we are at an even bigger picture. We are seeing a larger part of the earth, and the size is 1 followed by 6 zeros, 10 to the power 6 meters. That's called a megameter. So this size now is the state of California, or it could be the state of Maharashtra in India by the next to the Arabian Sea. So we now make it 10 times bigger. The next slide will show you an area which is 10 times by 10 times bigger. Now you can see part of the earth, right? 10 to the power 7 meters, 1 followed by 7 zeros. And you can see a large part of the earth. You know which country is this? Is the United States. Or another picture could have been in India. Okay. So now let's go to the next slide. Now you can, in this picture, which is 10 times bigger, the size is 1 followed by 8 zeros. So I'm every time adding one more zero. The next one will be 1 followed by 9 zeros. This is the Earth. You can already see background stars. The whole Earth has come in the picture. The man in the park, the first picture, is somewhere in the middle. We cannot see him, but he's there. So we are zooming out. We are seeing larger and larger areas. Let's make it 10 times bigger. Now, of course, this here I did not make it 10 times bigger. I just showed you a nice picture of the whole earth. Okay, you can try to search for India in this picture. Lots of water. You can see lots of water. 3/4 of the earth is water. So let's go further. Okay, now I've made it 10 times bigger, one followed by 9 zeros. One followed by 9 zeros is called 1 gigameter, 10 to the power 9 meters. Now, what are we seeing? This oval path is the path of the moon around the earth. The earth is here. The man in the park, the first picture is somewhere here. This is the earth, and this is the moon going around the earth. Okay. Now we have reached a size of 1 followed by 9 zeros, 10 to the power 9 meters. We have a long way to go because we have to see the whole universe. So you have to patiently wait for about 20 more slides till we reach a very large scale. Now, what is this? This is the moon going around the earth, and this long line is the path of the earth.
Orbit.
Yes, yes, orbit. This is the orbit of the earth around the sun. The small circle, uh, the, the small circle, the small circle is
Earth.
the small circle is the moon going around the earth. That was the previous slide. Let me go back. No, this is going forward. I have to. Uh, yeah, I was here. So this is the moon going around the earth. This is the larger line. This is the orbit of the earth around the sun. Now we have reached a size of 1 followed by 10 zeros, 10 to the power 10 meters. Orbit of the moon within the orbit of the earth. So earth's orbit is this big curve. Moon's orbit around the earth is the small curve. Let's proceed. Next slide. 1 followed by 11 zeros, 10 to the power 11 meters, orbits of Venus, Earth, and Mars. Now, the sun is still not seen. This is the orbit of Venus, this line. This is the orbit of the Earth. This is the orbit of Mars. Mercury has not yet come. It will come next slide. The man in the
Can we wait
park.
for a while?
Yeah, yes, yes.
Yes, yes. So 10 to the power 8 meters. क्या समझ आया? Sir, please ask you questions if you
Yeah,
can.
yeah. Questions we will, okay. How many zeros have we added so far?
11.
Yeah, we have added 11 zeros, and we have still not crossed the solar system. Yeah, you see, we have still not reached the full solar system, even though we have added 11 zeros, 10 to the power 11, and we have still a very long way to go. Okay, next. Now 12 zeros. Now, good. Now we are seeing the inner part of the solar system. Here is the sun, Mercury, Venus, Earth, Mars, Jupiter. The outer planets have still not come. And what size have we reached? 1 followed by 12 zeros, 10 to the power 12 meters. Okay, that's called a terameter. Now let's go 10 times bigger every time. And the man in the park is still somewhere here. Don't forget the man in the park. He's always there, but he's so tiny compared to the bigger things that we are seeing now. Okay. 10 to the power 13 meters. 1 followed by 13 zeros. The solar system. Now we are seeing the entire solar system, all the planets. The inner planets are in this box: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, Pluto. Everybody has come in this picture. Now we have reached the size of the solar system after adding 13 zeros. 10 to the power 13 meters is already huge. And you know how much time light takes to cross from one end to the other? It takes 8 hours. Imagine from the earth to the moon, to reach from the earth to the moon, light takes 1 second. even though it travels very fast. Light travels at about 4 lakh kilometers per hour. Traveling so fast, it takes 1 second to reach the moon from the Earth. But to cross the solar system, it takes 8 hours, even at that high speed. Let's go now. Let's go to the next picture. 14 powers of 10, 14 zeros after 1, our sun and the orbits of its planets. So here is the solar system now looking very small. But we have still not reached the nearest star. The nearest star is Proxima Centauri. We have not reached that even after adding 14 zeros. The universe has billions and billions of stars, but even after adding 14 zeros, we have not yet reached the next star. Let's go further. 15 zeros added, 10 to the power 15 meters. So here is the sun, the man in the park is here, the solar system is here, but there is lot of emptiness. These other stars that you're seeing are very far. We are not talking of them yet. We have not still reached the neighboring star. Still not reached, still lot of emptiness. 10 to the power 16 meters, 1 followed by 16 zeros. So still seeing only the solar system.
Now it's just a dot in the sky.
Yes, the solar system is just one small dot in the sky. All right. Now reach the nearest stars. Yeah, this is the sun. One of these stars, I think this one is Proxima Centauri. Then there's a star called Rigel. These are our nearest stars. Light takes about, from Earth to Proxima Centauri, takes about 4 years. Traveling that fast, it reaches the moon from Earth in 1 second. It crosses the solar system in 8 hours. But to reach the nearest next star, it takes 4 years. The travel time for light from here to here is 4 years. And for us, suppose we have to go in a spaceship to the nearest star, it will take 1 lakh years. We won't even survive that long. So it's impossible to go from here to here for one person unless we find faster ways to travel. Okay, now we are going to add one more zero. 18 zeros after 1. Can you believe it? 10 to the power. Write that number on a paper. 1 followed by 18 zeros. You cannot even imagine how big a number. Yeah, write 18, 1 followed by 18 zeros.
One के
So
बाद 18 zeros.
in this picture, there are about 1,000 stars which are in a distance of 50 light years. How much is 1 light year? 1 light year is the distance that light travels in 1 year. So 50, so if to go from one end to the other end of this picture, light will take 50 years. Okay? So, all right. Next, we have put 18 zeros after 1 and still the universe is not finished. Long way to go. All right. There are planets around other stars also. So not only does the sun have planets around it, lots and lots of stars have planets around it. The sun is here, the man in the park is here. Here I took some one star from this picture and I'm zoomed in. I made the picture bigger. This is the planets going around the other star. So lots and lots of stars have been found to have planets. We don't know whether there is life on those planets, whether there are people on those planets. We can't see that far. We need even bigger telescopes and other means to find out if there are life on other planets. But we know one thing, there are definitely stars around other planets. So, okay, we have added one more zero. Now 10 to the power 19 meters. Light takes 1,000 years to cross this box. So we won't even live that long. We are born and we die, but light is still traveling to cross this box. The man in the park is always in the center of the picture. The sun is now just one star in this picture. You cannot see it. And there are thousands and thousands of stars in this picture. We started from 1 meter. We have come to 10 to the power 19 meters. Few more powers of 0 to go. What are you seeing now? Why does it look milky or white? Because there are a very, very large number of stars in this picture. It's not that there is milk or there is ice cream. There are just too many stars. All the light of all the stars put together makes it white. So we are now reaching the size of our galaxy, the Milky Way. We have added 20 zeros after 1, 20 powers of 10. Light takes about 10,000 years to cross this box, and this is the part of our arm of the spiral of the Milky Way. Now we are reaching we have reached. This is our galaxy, the Milky Way. Okay, akashganga it is called in Hindi. And here is the sun. The sun is one of the stars. These are billions of stars. This is the center of the galaxy where there's a black hole. There are billions of stars in this galaxy, which is our galaxy, the Milky Way. All right, and we have added 21 powers to to 10. We have added 21 zeros after 1. Remember, we started with 1 meter and then we added 1 zero. It became the park, and now we have added 21 zeros and we have reached the Milky Way. Here is a big picture of the Milky Way galaxy as seen from far. Maybe some alien is watching us from some other galaxy. The sun is a star somewhere here. So the man in the park, he said, you are sitting here right now. You are sitting here somewhere where the arrow is looking at this zoom. But the galaxy is so huge, Milky Way is so big, light will take about 1 lakh years to go from one end to the other. It starts from here, goes very fast, very fast, very fast, very fast. But to reach here, it takes 1 lakh years. That is how big the galaxy is. Let's go. This is how the Milky Way will look if you look out for the Milky Way in the night. Go to the village, go to some village where the night sky is dark, city lights are less. This is one arm of our galaxy, the Milky Way. Okay, let's come back to adding zeros. We are getting to now the size of the whole universe. We have added 22 zeros after 1. Okay, light takes 10 lakh years to cross this box. This is the Milky Way in the center. The man in the park is somewhere in the center. You are somewhere here in one of the billions of stars of the Milky Way. And there are two smaller galaxies. These points you see, these fuzzy points, this is the large Magellanic Cloud and the small Magellanic Cloud. These are two galaxies which are smaller than the Milky Way, which are going around the Milky Way. What is this? This is the neighborhood of our galaxy. Our galaxy and its neighbors, other galaxies. Let me show you. So we have added 23 zeros after 1. So the Milky Way is this shiny point in the center, and there are other galaxies. Let me show you. Though, look at this. This is a picture taken by the Hubble Space Telescope. Every spiral kind of shape that you see in this picture is a galaxy. You see this? Most of these are not stars, they are galaxies. See this shape, this spiral disk shape. This is a galaxy, this is a galaxy, this is a galaxy, this is... And our galaxy is just one of these. Maybe it is this one. Okay. Maybe, sorry, this is another picture. Maybe our galaxy is one of these. Each galaxy has billions of stars. Our star is one of them. The man in the park is somewhere here, but the overall universe is so much bigger. This is a close-up of different galaxies from that picture. These are actual photographs. Okay. Galaxies form clusters. Just as there are a lot of stars in one galaxy, there are a lot of galaxies in clusters. So these are different clusters of galaxies. A cluster may have about 1,000 or 10,000 or so galaxies. Different clusters together form what is called our neighborhood Virgo supercluster. This whole thing is called the Virgo supercluster. I've added 24 zeros to 1. Next, each of these is a supercluster now. The Virgo supercluster is in the center. Inside the Virgo supercluster is our cluster. Inside our cluster is our galaxy. Inside our galaxy is our star. But just see the size of things. I've added 25 powers to 0. Now this is the last picture of this set. I've added 26 powers to 0. Each of these dots is a supercluster. Can you believe it? So millions and millions and billions of galaxies. This is how far we have seen. The man in the park is in the center of this picture. But what next? Why can't I make it 10 times bigger and show you the next? Because we have not seen that yet. Our set, we see these with telescopes. Our telescopes are not so powerful. So we have a question. Does the universe go on forever? Can I make it 10 times bigger? Or does it come to an end? And if it comes to an end, what is after the end? We don't know. We don't know the answer. We don't know everything. See, we know a lot of things, but we don't know everything. So when you grow up, please work to find out the answer to this question. Does the universe go on forever or does it come to an end? So at least my slideshow has come to an end. I'll play a 1-minute movie to show you everything in a summary. Okay, so this is the last part of the talk. I want to tell you in this video, I'll show you a movie which is 4 minutes long, and I'll tell you the kind of work scientists are trying to do to find out how big is the universe. After this, the talk will come to an end. This movie will be for 4 minutes. Please watch it carefully because one of your activities is draw the universe. So you have seen the universe, then you have to draw it. So watch this carefully.
Somewhere in the universe is a small blue planet, the third rock from a star called the Sun, just one of billions of stars in a spiral galaxy known as the Milky Way. But where in the universe is the Milky Way? A team of scientists gathered data on more than 8,000 of the galaxies that surround us. They mapped each galaxy's position and movement in space. And, for the first time, they've shown that the Milky Way is part of a much larger system of galaxies, a supercluster that they have named IUCAA. The Milky Way is nested in the furthest reaches of this structure, on the outskirts. The entire universe can be seen as an intricate network of galaxies, a cosmic web. Some areas are almost empty, dark voids. Others are densely packed with galaxies in regions known as superclusters. Superclusters are the biggest structures found in the universe, but scientists have struggled to define where one ends and another begins. To map our home supercluster, a team led by Brent Tully at the University of Hawaii studied the motions of the galaxies around us in unprecedented detail. Even though the entire universe is expanding rapidly, gravity is also at work, pulling against this acceleration. By discounting cosmic expansion, the team worked out which galaxies are being pulled towards us, shown in blue, and which are being pulled away, shown in red. This enabled them to create a map of cosmic flows, the paths that galaxies migrate along, tugged at a tiny pace by the force of gravity. Using this motion, they came up with a new way to map the distribution of matter in the universe. Delving into our home supercluster, you can see that most galaxies are being pulled towards a dense center. This is known as the Great Attractor. Our galaxy is among those sliding towards this patch of space, which dominates our region of the universe. Let's take a different view. Each circle represents a galaxy. Again, we can see most galaxies being pulled towards the Great Attractor in the direction of the arrows. Between the Great Attractor and us, the Milky Way, is a relatively empty area, a blue void. And next to us is Virgo, a large and dense cluster whose bright galaxies have been observed from Earth for centuries. Until now, astronomers grouped us, the Milky Way and its surrounding galaxies, with Virgo and nearly 100 other clusters in a supercluster that stretches 100 million light years across. But you...
Samarth, can you stop that? Otherwise, I'll throw you out. Okay? Don't do it.
In this new technique, we can see that this is just the tip of the iceberg. This cluster of clusters is merely an appendage of a much larger supercluster, more than 100 times bigger and more massive. But how did the team know how to redraw the boundaries of this cosmic map? Here's our supercluster in black and a neighboring structure, Perseus Pisces, in red. Scientists defined the boundary as the points where the flows of galaxies diverge, like water dividing at a watershed. This is where neighboring structures shear apart. This is the first clear definition of a supercluster. Laniakea means immeasurable heaven in Hawaiian, a fitting name for the vast community of galaxies that we are a part of. So now we know that on the edge of a supercluster called Laniakea, in a galaxy called the Milky Way, around a star we call the Sun, there is a small blue planet, our home.
Great. So can you hear me? I hope you get, Samarth, what is this? You shouldn't be doing this. Okay, that's not good. So I hope you got some picture of what the universe is like. And now are you ready for the activity? Are you ready for the activity?
Are you all ready for the activity?
Yes.
Very good, very good. So I think I should unmute everybody, all participants to unmute themselves. Yeah, so now everybody can, you can unmute yourself if you want to talk. What you have to do now, I hope those of you who are taking part in the activity, you need 2 balloons, okay? On each balloon, you have to mark 2 points. Those of you who have balloons, please mark 2 points on each balloon, 2 centimeters apart. Take a scale, mark 2 points on each balloon, 2 centimeters apart. And then mark a third point anywhere. Mark a third point anywhere on each balloon. 2 points which are 2 centimeters apart, and the third point which is anywhere. In the meanwhile, if any of you want to ask questions, you can do that also. Or if you have balloons and if you are doing the work, you can do that. So after you have marked the points on the balloon, you are supposed to inflate the balloon. One of them you will inflate half the size of the other. So one balloon you don't inflate too much. The other balloon you inflate a lot, but not so much that it bursts. So the balloon, the inflated balloons are our universe. One thing I forgot to tell you, that the universe is expanding. The galaxies are going away from each other. Expanding doesn't mean that I'm becoming fatter or you are going away from me. No, stars are not going away from each other. But
Just a minute, sir.
Yeah.
Sir, so what we have to do is we have to make 2 marks on these two balloons, and then we have to uh,
Blow
inflate
up.
them, right?
You have
Blow.
to blow up both the balloons. One, a lot of blowing up, the other, less blowing.
Yes, yes.
And after blowing, you have to tie it up so that it stays like birthday balloons. We need to, yeah, good. Who is this? Good one. Flashcards. Very good. You did a good job. Excellent.
Start karo.
If you can, please show me the balloons.
Yes, yes. So you have to make 2 marks. Okay, just make 2 marks on these
Very good,
balloons.
very
2
good.
marks.
Excellent.
All
Now,
right? And then
can you see
start
the
blowing
points
them.
that you had marked? Can you see the points that you have marked? Measure the distance between
One
the
dot on
points
each
that you had
balloon.
marked for both the balloons. The points are there, no? They were earlier 2 centimeters apart. Now measure the distance between the points on each of the balloon and write down your answer. You can put your answer in the chat, both the numbers. How much is one of them? How much is the other one? Okay. So you can just enter your answer in the chat box.
Okay. Both the balloons.
So if you have any answers, you can say it. Anybody, please? If you make the two measurements, got some numbers, please say your numbers.
8 centimeters.
Ah, one of them is 8. And the other one?
4.
Other one is how much?
4.
4. 4 is it?
Yeah.
Great, excellent. So one is more than the other. Very good. Rishi's answer is 4 centimeters and 8 centimeters. Earlier it was the same. It was 2 for both of them. But now one of them is 4 and the other one is 8. It means as the universe is expanding, the distance between galaxies is increasing. The 2 points are 2 galaxies. As the balloon is the universe. Your balloon is your universe. The smaller balloon is the less expanded universe. The bigger balloon is the more expanded universe. And in the universe that is more expanded, these galaxies are farther. They are 8 centimeters apart. And in the smaller universe, they are only 4 centimeters apart. So the universe expanding means space is stretching. The blowing of the balloon is like the stretching of space. As space stretches, galaxies move away from each other and the universe is becoming bigger and bigger. So not only is the universe huge, not only is it enormous, it is getting even bigger, which means in the past it must have been smaller. If it's growing bigger and in the past it was smaller, 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 until everything was in collapse to one point, that is what we call the Big Bang. For some reason that we don't know, about 10 billion years ago, there was a huge explosion called the Big Bang, which threw out all the matter that we see in the universe. That matter later became stars and galaxies. The explosion, the Big Bang threw everything out, and the things that are thrown out are still expanding. The impact of the Big Bang is still there, and the universe is growing and growing in size, but at the same time, it is forming structures like galaxies and stars. So what you have done in this activity is demonstrated the expansion of the universe by making balloons of different sizes. Vinita, is the activity over or still doing? Vinita, are they done? Are you on mute, Vinita? Please unmute yourself.
Sir?
Yeah. Anybody else made a measurement? Who's speaking? Anybody else made a measurement of the balloon points?
Second.
Who is saying something? Vinita, should we move to the next activity? Those of you who have finished the balloon activity, please start the second new activity. What you have to do now, you have 15 minutes. You have to draw the universe. You saw all these slides, you saw the video, you saw the movie. So draw what is your picture of the universe. You can see, arrow, very good. 8.2 centimeters and 4.6, excellent. You see the points are gone farther apart once you blew up more. That is because these galaxies have moved away from each other because of the expansion of the universe. If you blow even more, they will go even. So today when you go home, you can make a few balloons. Always make 2 or 3 points 2 centimeters apart and then blow them to different sizes and do the measurement, and you will understand expansion of the universe. Okay, now the second activity, take a piece of paper, drawing paper, maybe crayons or sketch pens, and draw the universe. After 15 minutes, you have to hold the universe, your picture of the universe, to the screen. And I'll take a screenshot of all the pictures and then share it with all of you. And we will have a collection of universes. So your time starts now. Please draw the universe. Flashcards also has answers. 6 centimeter and 6 centimeter. It came the same, beta. Your same on both the balloons. The balloon sizes were same. You can unmute yourself and talk. Yeah, you can unmute your, yes.
I am sorry, it was fourth. I by mistakenly typed.
4 and 6.
Yes.
Yeah, very good, very good. So do you understand how this explains expansion of the universe?
Yes, the
One of them is less far, the other one is more far.
yes.
So everybody is drawing the universe? So if you are finished drawing, you can show it, or you can take 5 more minutes, or you can, if you want to ask questions, you can ask questions. Vinita, they are drawing?
Yes, sir, they all are drawing.
Okay.
And I'll ask them one by one so that they can ask one or two questions from you, right?
Yes, yes. Someone is
Okay.
asking, is collection of universes called a super cloud? No, beta, there's only one universe. There are no collections of universe. There's only one universe, right? We don't think that there are some people say there are many different universes and they all put together call it multiverses. But we have not seen them. We can only believe things that we have seen.
Hello, my name is Athar.
Yes, please go ahead.
I would like to ask what is the Roche limit?
Roche limit, yes, excellent, very good question. Let me see if I remember it correctly. Yes. So if you have two stars, going around each other in a binary orbit, and if one star's gravity is much stronger than the other star's gravity, it will pull material from that star. The weaker star will get blown out and pulled out to the bigger star. If it is too far, it will not get pulled out. If it comes close, it will get pulled out. Roche limit is the farthest it can be before it will get pulled in. Okay, Roche lobe has to do with the limit. Roche limit you asked, no?
Yeah.
Yeah, so do you get what I'm saying? Roche,
Yes.
if you get too close, you get pulled. That is the Roche limit.
It's like when a weaker magnet gets closer to a stronger one, it gets attracted.
Yes, that is the same concept. Very good point you made. The concept is the same. If you get too close, you'll get pulled in. How close you have to come before you will get pulled in, that's the Roche limit.
Can you tell me what is a neutron star?
Ah, very good, very good. All right. So everybody's listening. Let's see. People are still drawing, no? Let's wait for because your question is very good. I want to wait till everyone has finished drawing. Then we'll start the questions, okay? So that everybody can take part.
He is the one who is very interested in knowing about space.
Very good, beta. Very. What's your name? Athar.
Athar.
You finished drawing the universe?
I wasn't able to draw the universe. I'm not that good at drawing.
But you didn't try, is it? You didn't try at all?
I made the Super Saturn, also known as J407b.
You drew something. Show me what you drew. Whatever you drew is good. That's the universe. You just show it on the screen. All drawings are good, beta. No one is a bad drawing. Yeah, okay. Let me see if I can see. Come closer to the screen. Come. We want some more light if possible. Okay, I need more light. But you can do one thing. Give it to Vinita ma'am. She'll WhatsApp.
I'll click the pictures from all the drawings and then send it to you.
ठीक है. Very good, very good. So
Write
that
down your name.
you can collage them. You can collage them and share with everybody.
Yes, sir. Yes, sir. Go to your place.
Show me your universe, please. You finished? You took the last movie, no? Excellent. So everybody please see flashcard. What's your name, beta?
Athar.
No, Athar was there in flashcard.
My name is Rudra.
Rudra. And everybody have a look at Rudra's drawing, please. So interesting. He has taken the last movie where the superclusters were being shown. Or is this a galaxy? No, it's a supercluster. What were you drawing, beta, Rudra?
That Milky Way.
So Milky Way galaxy. Very good. And very good. And who else on the top right? Who is that? Let's see. Arav, show me your drawing. What have you drawn? It's a galaxy or the solar system?
Sir, that's the Milky Way.
Excellent. Very good. Who else is there? Deepa Mani. Please unmute yourself.
So actually, I'm Isha.
Isha is your name.
Yes.
What
I
have you
made
drawn,
this.
beta? What have you drawn?
So I've drawn all this, the orbit and all these things.
Take your picture a little away. Yes, you have drawn many things. Excellent. And what are the orbits?
So my camera is a bit blurry, so it's
Doesn't
not.
matter. Doesn't matter. So you have shown orbits of
So the yellow thing is like the root Milky Way.
Uh-huh.
This is the orbit.
Excellent. Very good. I'm very happy.
This was the thing which was kept over there, the thing like the monument thing.
Yes,
Is
yes,
kept-
yes. Did somebody draw the whole
And,
universe? Lots
and
of
this
galaxies.
was this.
What is this, beta? This is also an orbit?
The galaxy.
Galaxy, galaxy. Very good, very good.
This is the sun rays when our star went close to the sun.
Yes, yes, yes. Who else? Rishi, show me your picture, please. What have you drawn, beta? Keep it little away. What have you drawn? Tell me. Yeah, tell me by saying what have you drawn?
Universe. Whole universe.
I want to see your picture. Well, maybe make it brighter. Maybe make the light level higher. WhatsApp it to me, Rishi. WhatsApp it to me. You have my number. WhatsApp it to me. I'll see it.
So this is Samira. She is
Very good. Samaira, what has she drawn?
The Milky Way.
The Milky Way. Very good. So looks like the Milky Way has impressed everybody. The most interesting thing is true. It's a beautiful picture. Our galaxy is quite beautiful.
and she has some questions to ask.
All right. So let us, anyone else has a drawing to show? Sia, did you
So my
make?
students will, when my students will come to the seat, they'll show the drawings and ask the questions.
Okay.
Is it okay?
Sia, did you draw something with her? Unmute yourself, Sia. Do you know how to unmute yourself? Yeah, please unmute yourself. Okay, it's not getting unmuted. Did you draw universe? Yeah, did you draw universe? Okay, you can WhatsApp it to me, beta. I'll have a look at your picture. Rishi, Rishi has sent me his picture. Lovely. Milky Way in the center. All the galaxies, the whole universe. Very good. Next time, Rishi, make it in color, okay? Make it with crayons and sketch pens or watercolor. Excellent. The idea is excellent. You have actually drawn the whole universe, right? The Milky Way in the center and lots and lots and lots of other galaxies. Very good. Next time, make it with sketch pen and color and send it to me. Anybody else wants to?
Yeah.
Okay. Okay, great. So now we start the question answers. Anything you want to ask me about astronomy? If I know the answer, I'll tell you. Otherwise, I'll Google it and tell you, or you can Google it yourself. Okay, go ahead, please ask your question.
Okay, Samira? Yes.
I wanted to ask first question, why is Neptune blue?
Why is Neptune blue?
Yeah.
I don't know the answer, but I'll have to Google it. Let me ask Google. Google, why is Neptune blue?
According to Cool Cosmos, Caltech, the methane in Neptune's upper atmosphere absorbs the red light from the sun but reflects the blue light from the sun back into space.
See?
This is why Neptune appears blue.
Google is very helpful. So what is happening? Sunlight is falling on Neptune. There is a lot of methane in Neptune's atmosphere. Methane has the property that it absorbs the red light. The sunlight is made of which colors? You know, Vibgyor, blue, violet, indigo, blue, green, yellow, orange, red. The methane absorbs the red. So what is left mainly is blue. Whatever is not absorbed is reflected. Very good question. So thank you, Google.
Second question, why does human body get taller in space?
Taller? Is it? Well, it would get stretched. I don't know how much taller it gets. If gravity is weaker, see, gravity is pulling us to the earth. If gravity is weaker, then there will be some stretching, especially if you fall towards a black hole, the gravity is so strong, it will stretch you like a noodle, you see. It's all because of presence of gravity or absence of gravity.
Okay, sir. Thank you.
It's because of the contraction of the spine due to the gravitational force in the space.
Who's talking? Who's talking? Arav, say it, Arav. What are you saying?
So the spine gets stretched due to the gravitational force present in the space which acts upon the spine of the human body.
Yeah. So because of the weight conditions and the gravity conditions are different, that can cause some stretching. Yes. Okay, Rudra, please ask.
Why is gravity less in space?
Because it is like this. The answer can be given in a mathematical way. The Earth is pulling all bodies towards itself because of its gravity. Yeah. The moon also has its own gravity. Moon is pulling towards itself. Sun has its own gravity. It is pulling towards itself. So why are we not going towards the sun or the moon? Why are we going towards the earth? Because we are close to the earth. The mathematics says that the strength of gravity falls as you go away from a body. There's a formula for it. Larger the distance, less the gravity. Who asked this?
Rudra.
Yeah. And take any body like the earth. If you go away from it, the force of gravity becomes weaker inversely with distance. Now you are asking, why does that happen? I don't know the answer to that why. I can tell you an experimental fact that as you go away from a body, its gravity becomes weaker. And I can prove it with mathematics. When you grow up, I can write equations for you to prove. This is the law of gravitation that Newton found in 1687. Newton discovered the law of gravitation. Which class are you in, Rudra?
I'm going to seventh.
Okay, so you understand some maths you have done, of course, right?
Yes,
So
sir.
the force with which the earth pulls other bodies falls as 1 by square of the distance from the body. Do you understand what I'm saying? Or is too technical? Suppose there is a body in space which is at a distance r from the earth. The force on it will be mass of the earth divided by the square of the distance. If the distance is more, the force will be less. There's a formula for it. Okay?
Okay.
More questions? Who are? Yes, I see one hand up. Trinav, yes, please unmute yourself.
Sir, so I have a question. If black holes are so dark, then how are we able to see them?
Very good, very good. We don't see a black hole directly, but many black holes are parts of binary stars. There is another star going around the black hole, and the material from that star is getting sucked into the black hole. Like the Roshlov limit that somebody asked about, that has been reached. Material from the star which is going around the black hole is getting sucked into it. As it is getting sucked in, it emits X-rays. Those X-rays are what we observe. And by looking at the X-rays, we know that they are coming as if something is going around something else. So then we conclude the presence of a black hole by looking at neighboring stars. Do you understand that?
Yes.
Yeah, it's like suppose you are in a dark room. You cannot see anything, but you hear this sound. Meow. You know there is a cat in the room, even if you cannot. So things which are not seen, but whose presence is felt even though they are not being seen. So we know because of the binary that something, similarly, there is a huge black hole at the center of our galaxy, which we cannot see. But the stars that are going around the black hole in the center of the galaxy, looking at their orbit, we know that they're going around something, which is the black hole. Okay? Rishi, what's your question, beta?
Question, Rishi. Ask.
You ask.
Ask.
You ask.
No, children have to ask, beta. Mama cannot ask. No mamas are asking. You ask, beta. I'll answer. You ask.
Why is
Pluto the coolest planet?
Why is Pluto the coldest planet? Very good. The same kind of question. Why is gravity weaker when you go away from an object? A light is coming from the sun. The farther you are from the sun, the less is the light. The heat is because of the light of the sun. If you go farther and farther, the light will become less and less hot. Pluto is the farthest, that is why it is the coldest. Mercury is the nearest, that is why it is the hottest. Do you get that? Earth is lucky. Earth is lucky. Not too close, not too far. Just correct. Very pleasant. Ah, the weather is so nice today. Can anybody at Mercury say the weather is so nice today? No, that's Arey Bapre, it is so hot. I'm melting. Can anybody at Pluto say the weather is very nice? No. They say, oh, I'm freezing. Earth is lucky.
You're lucky. Yes. Thank you.
Who else?
Sir, Priyansh wants to ask you a few
Yes,
questions.
please. Yes, please.
Priyansh?
Hello, sir. I want to ask you one question. Do white holes actually exist?
Ah, good. Very good question. We have not seen any. There is no reason really why they should not exist, but we believe only those things which have been detected in experiment or in observation. No white holes have ever been seen.
Sir, I have one more question.
Yes.
What was there before the Big Bang?
Yes, very good, very good. I don't know, I don't know. But you have to, there are two possible answers. That correct answer is that nobody knows the answer. Two possibilities are there, which we don't know which of these is correct. One is that the universe, there is a universe which exists forever, ever, eternal, from past in infinite time. And events like Big Bangs keep happening once in a while. The Big Bang happens, after a few billion years, somewhere else, another Big Bang happens. So Big Bangs are happening all the time, and the universe has existed forever. Now you can ask, why is the universe there? Why is it that there is something rather than nothing? We don't know the answer. It's a very deep question.
Sir, so after
Let me
like a lot
complete.
of
Let
time,
me complete. I have not completed. One possibility is that it existed forever. The other possibility is that the very concept of space and of time are created with the Big Bang. So it's not meaningful to ask what was there before the Big Bang. There was no time and there was no space. The very idea of time was born after the Big Bang. But I don't think this is correct. In my picture is that there was something before the Big Bang, but I cannot say what it is. Maybe it was just mathematics. You see, we think that mathematics and physics are different. Mathematics is numbers, 1, 2, 3, 4, 5. Things are things, one phone, 2 crows, 3 boys, 3 girls, 4 girls. But maybe at a deeper level, mathematics and physics are the same thing. Physical things like what are also numbers really. Mathematics is more fundamental than the physical world. So maybe there was mathematics before the Big Bang. But then you will ask, where was the mathematics? Where is the number 1? Is it here or is it there? I don't know. Numbers don't need space to exist. They just exist. Okay, what was your question next?
Sir, so like you're saying that after some time, this universe will end, the universe will start.
This won't end, but another will start.
Oh,
One more Big Bang may happen, but I don't know. These are just ideas.
okay.
We don't know why the universe is there, why it started, how it will end. Is it going on forever or not? We don't know. All right. Rishi, what's your question?
What's your question?
Why is Venus the hottest planet?
Venus is hotter than Mercury, is it?
Yeah.
Oh, very good. I don't know. I'll have to Google it. Let's see. Let me try see if I can find out. Why is Venus hotter than Mercury?
According to University College London, Venus is the second planet from the Sun, but is still hotter than Mercury. This is because the atmosphere is very thick and is made up of greenhouse gases such as carbon dioxide. It also has traces of nitrogen, and the clouds on Venus are made up of sulfuric acid.
Very good. So Google, thank you, Google. So what it is saying, how hot a planet is does not depend just on how far it is from the sun. It also depends on what is the material on the planet. So Venus has lot of carbon dioxide, which is called a greenhouse gas. What is causing global warming on Earth right now? Carbon dioxide. Lot of carbon dioxide in the atmosphere. So Venus has much more carbon dioxide in the atmosphere than Mercury does. So the sunlight is absorbed by carbon dioxide, which retains a lot of heat. And that is what makes it even hotter than Mercury. Do you get it, Rishi?
You understand?
Because it has a very large amount of carbon dioxide, a thick atmosphere. Thanks, I also learned. I did not know before you asked.
Thank
All
you.
right, who's there now?
The next student is Akshita,
Yeah, beta, go ahead.
Good
my
evening, sir.
daughter.
Oh, so nice. Well, nice to meet you, Akshita. How are you?
Nice to meet you, sir. I'm fine. How are you?
I'm good, beta. Did you get some idea from the talk?
Yes, sir.
Please ask your question.
Yes. Sir, I wanted to ask, why did the Big Bang take place?
Yeah, that question was just asked. The honest answer is that I don't know and nobody knows, but I can give you some idea, my own thinking. Suppose you have gas in a box. You understand what I'm saying? That is made up of molecules. They are all over the box. Suppose for some rare event happens, all the molecules of the gas go to one corner of the box. You see what I'm saying? The rest of the box gets empty. All the gas is pushed to one corner of the box. What will it do next? It will explode to spread out to the rest of the box. You understand? The Big Bang may have been something like that kind of an event where before the Big Bang, all the matter was for some reason compressed to one point and then it exploded. So such rare events are very, very unlikely, but they are not impossible. Like suppose there is air in this room. So we said, of course, it can never all go to one corner. But there is a very, very small probability that once in a few billion years that might happen. Or when I break an egg, when an egg falls from my hand, all the eggshells fall back on the ground, the egg is spread and splattered. Have you ever seen the egg pieces coming up to and joining each other together to form a full egg? Have you seen the reverse process? Egg pieces are lying on the ground. They all nicely come up and join to form an egg. Have you seen that?
Yes, sir.
Where have you seen this, beta?
Sir.
No, our egg has broken and all the pieces are fallen on the ground. Now I'm saying, is the following possible? The pieces on the ground say, oh, we don't want to break, we want to form the egg again. They all rise from the ground, come back and join together to form a proper egg.
So that doesn't happen.
Ah, excellent. That event is very, 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 very unlikely, but it is not impossible. Maybe once in a few billion years, an egg will do that. Same way, the Big Bang may have been a very, very unlikely event, but not an impossible event, where all the matter was compressed to one point and the explosion formed the Big Bang. Do you get it better?
Thank you, sir.
Okay, thank you, thank you.
The next one is Atharv.
Hello.
So, दूसरा अथर्व है.
Hello, sir. My name is Atharv.
Yes, please go ahead.
My question is, what is the shape of the universe?
Excellent. Again, these are very difficult questions. We don't know the answers. If it is endless, endless, you understand, infinite. If it has no end, then I don't know how to talk of its shape. If it has a boundary, then I would say it is the shape of a sphere. What does that mean? You see, do you understand a sphere?
Yes, sir.
If you go, the surface of the earth is a sphere. You start going from Delhi, you go around the earth, you will come back to Delhi, right?
Yes, sir.
Why does that happen? Because the earth is round. The earth is not endless. It is not endless, and you come back to the starting point. The universe could be like that. It could be round. You start from our galaxy, you go to Andromeda, keep going, keep going. And before you know, you'll be back to the sun or to the earth. Why? Because the universe is round. Maybe the universe is like a sphere, but we don't know. We don't know. You should find out.
Sir, I have been seeing videos on the internet that it looks like a cell of the brain.
Looks like
A cell of the brain.
the universe looks like a cell of the brain.
Yes, sir.
I've never heard that, beta. Don't believe these things. Okay. Well, maybe what they are referring to is the filaments. Maybe they are referring to the filaments. Did you watch the movie, the last movie? In the movie, yes, maybe that's what they are referring to. The universe is made up of filaments along the. Do you understand filaments? Strands. Lot of strands joined together. In between, there is empty space. Galaxies are on the strands, and empty space, there are no galaxies. In the brain, the neurons are distributed like that. That's what they're saying, maybe. The neurons are distributed along filaments, and that, yes, okay. But it looks like the universe, but I don't know whether to attach any deep meaning to that.
Okay, sir.
What else?
So the next student is Abhilasha.
Come, beta.
They have a very big list, sir.
No
I have
problem.
restricted them right now.
I have
said,
all the time. I have all the time.
sir, but they have to leave for another classes.
Okay, so you decide when to end, then they can send WhatsApp messages
Yes, sir.
to
Definitely.
you.
Okay, Abhilasha.
Sir, I want to ask that how a black hole is formed.
Yes, very good question. Most of the time, black holes are formed when a star's life ends. A star does not live forever. A star, let's take the example of the sun, or a even more star which is even heavier, let's say 10 times heavier than the sun. It is emitting light because It is burning hydrogen. Hydrogen is getting converted into helium in the star. Because of that, energy is released. When all the hydrogen in the star will be used up, there'll be no more fuel. There'll be no burning possible, and the star will stop shining. When it stops shining, there is nothing coming out, and its gravity is going to start pulling it in. The reason the gravity is not pulling the sun inwards right now is because of the light that is coming out. The light is pushing outwards, so the gravity of the sun is not able to pull the star in. The moment it stops burning hydrogen, there is no light coming out, its gravity pulls it in, and then it shrinks, and forms a black hole. Black holes form after the life of a star has ended. Does it answer your question? You can ask more things, beta. If you are not clear, you can ask more.
Really?
Hello?
So it's imaginary.
What is imaginary? Vinita, what is she saying? I'm not getting.
Sir, I'm saying that is a black hole like really in the universe of
Yes, at least black hole-like objects definitely exist. As I answered in another question, if in a binary star, if you see a star going around something else and you don't see that something else, you know there is something, and that is likely to be a black hole. Because of the gravitational influence of a black hole, we can infer its presence.
Thank you, sir.
Okay, thank you.
The next student is Dia.
Hi,
Uh,
I've been waiting for a very long time.
yeah, go ahead, beta.
hi, sir. My name is Dia.
Hmm.
Sir, my question is that how the sun works?
How does the sun work?
Abhi?
Sun, is it? How does the sun shine? Is that what you're asking?
Yes, sir.
What is your question, beta? Say it again.
Sir, how does sun works?
Yeah. Why does sun shine? That's what you're asking, no? Yes, the sun has lots and lots of hydrogen because of something known as nuclear reactions. The hydrogen is getting converted to helium. Hydrogen atoms like to combine to form helium. When hydrogen becomes helium, energy is released. That is what is called sunshine. The sun shines because it converts hydrogen to helium. Fuel, the way, for example, petrol burns in a car and releases energy which makes the car move. Same way, the burning of the hydrogen fuel converts hydrogen to helium and releases energy. One day all the hydrogen will be finished. The sun will stop shining. Then we'll also be finished. But that will come after a long time. Yes.
Thank you, sir.
Okay, beta.
So the last student is Aryan. ये हमारा
Yes.
सबसे प्यारा बच्चा है सर.
Very good. He looks very cute. How are you, Aryan? Please ask your question.
Sir, what is the work of an astrophysicist?
What work does an astrophysicist do? So did you watch the movie? Did you watch the movie? You saw the movie, no? Powers of 10, the slide that are you, yeah. Where did all that knowledge come from? Who took those pictures? Who found out about the Milky Way? Who found out about other galaxies? What's going on? Yeah, so The job of an astrophysicist is to look through a telescope and observe stars and galaxies and to find out what all is there in the universe, how did the universe start, where is it going, like that. Do you understand what I'm saying? Main job is to look through the telescope. Okay. We have done, Vinita.
Thank you so much, sir. Actually, I wanted them to ask at least one question so that they don't leave the habit of questioning, because I
Yeah,
think that once we grow, we all start questioning. So
Yes,
that was
yes.
the main
Yeah,
perspective of the
I
session.
hope they got something from the movies.
Definitely,
But
definitely.
they got some picture, yes.
They have big lists of questions, so I'll send you all the questions, and probably we will look for more events like this. And
Yeah,
we
we
are
can.
very thankful that we are connected to a person like you who is so knowledgeable and
Oh,
yes,
thank you, thank you.
always ready to help our miracles of science.
You're
Thank you, sir.
talking
Thank
to
you
the
so much.
children, yes. Thank you. Shall we log out? Any more
Yeah.
questions? Anybody on the Zoom link? Kranti has a question in chat. Will the universe come to an end? All right, very good question. Again, we don't know the answer. Probably keep on expanding forever, becoming darker and colder. That is the only way it can end. Okay. Any more questions? Rishi, you have a question, beta? Rishi, you want to ask more questions?
You want to ask more questions? You want to ask? Ask.
Ask, beta, ask.
Yeah.
Pluto have light coming out.
Does Pluto have light coming out? Ask.
Does Pluto emit
Light coming out.
Does Pluto have light coming? No, no planet has its own light. Sun shines because, as I said, sun burns hydrogen to emit light and energy. Planets do not have their own source of emitting light. The only light that planets emit is because of reflection of sunlight. Because Pluto is so far, it will not receive enough light to start reflecting anything. But again, let's ask Google. Google, does Pluto shine? Does Pluto get a Pluto? Let's see, this is what Google says. Pluto orbits on the fringes of our solar system, billions of miles away. Sunlight is much weaker there than it is here on Earth. Yet it isn't completely dark. In fact, for just a moment near dawn and dusk each day, illumination of Earth on Earth matches that of high noon at Pluto. So maybe it's like very little, very little, not zero, very little light.
Any other question? No?
No.
Kranti is asking, where do most comets come from? There is a region in space outside the solar system known as the Oort cloud, O-O-R-T. Oort was the person who found this cloud. Most comets that go around the sun are believed to originate in the Oort cloud. All right. Should we go home now, beta? Should we all go home? Any more questions? Vinita, should we wind up?
Sir, yes, sir.
Thank you.
Sir, I have a question.
Yes, please go ahead.
Sir, I can see few drawings, some paintings in your background. Are these from space?
No, these are just home pictures.
No,
No.
the other side, the other side.
Some pictures are space pictures. Yes. That's just these are artists' imagination.
Okay, all right.
No, artists like to. That's why I wanted the students to draw the universe I want to see what they have drawn. Yes.
Okay, probably some of our students may become the scientists or some may become the
Yes.
artists, but definitely the love for the knowing about universe will definitely remain same.
Yes, yes.
Yes,
And
sir.
you know,
Thank you,
like
sir. Thank you so
I
much.
like the last video which was made, which I should have made only 10 years ago. We know very little about the shape of the universe. We are still learning. We're still learning.
Okay, sir. Thank you. Thank you so much.
All right. Bye bye, everybody. See you next time. I'm logging out. Okay.
Okay, bye.
Bye.
Bye.